These VEO3 ads are absolutely crushing it right now. We're talking millions of views, brands spending six figures to recreate what you're about to learn for under $1. I'm not talking about some basic AI video generator, no. I'm talking about a complete automated marketing machine that takes those viral ad formats everyone's obsessing over and customizes them for any brand you want, in any format you need. But here's what nobody's telling you. Most people are doing this completely wrong. They're manually copying prompts, spending hours tweaking settings, and burning through credits like crazy. What I discovered is that there's actually a way to automate this entire process using N8N workflows that can pump out professional-grade ads faster than any marketing team could ever dream of. I spent the last month reverse engineering exactly how these $100,000 ads work, breaking down the psychology behind why they convert, and building a complete system that does all the heavy lifting for you. We're talking about the same ad quality that brands like Tesla, IKEA, and major sneaker companies are paying agencies massive retainers to create. By the end of this video, you'll have a complete automated ad factory that can take any brand brief, any product, any message, and turn it into scroll-stopping vertical ads that look like they cost a fortune to produce. This isn't theory. I'm gonna show you the exact workflows, the prompts that actually work, and how to set up your own 107,000 AI marketing team for the cost of a coffee. The arbitrage opportunity here is insane, and I don't know how long this window stays open. So if you've been wondering how to actually make money with AI beyond just playing around with ChatGPT, this is it. I added the AI tools that we're going to use in the description so you can check them out. I want to give you a quick look at the demo workflow. It's the easiest way to see what's going on before we get into the real build. In this run, we will generate a 16:9 video using the VEO3 model. Alright. First, I will enter a short idea of the scene, then choose the aspect ratio and model before executing the workflow. The important choice here is between VEO3 Fast and VEO3. The Fast version is much more affordable, while VEO3 costs more but produces higher quality. The workflow itself is divided into three parts: prompt creation, 9:16 video generation, and 16:9 video generation. Conditional branches automatically decide which path to follow based on the format I select, so the process stays flexible and efficient. I'll begin by executing the workflow and entering a brief idea of the video. For this demo, the idea is simple. In a bright, empty room, a closed IKEA box shakes, bursts open, and the furniture inside assembles itself into a full setup with a bed, wardrobe, lamps, shelves, rugs, and plants. At the end, a yellow blanket falls on the bed and the room looks calm and complete. After entering that idea, we will set the aspect ratio to 16:9, choose the VEO3 model, and submit. As the workflow runs, I can see each section in action. The first section is prompt generation, where the AI expands my idea into a full creative prompt. Then, the conditional logic directs the process either to 9:16 video generation or to 16:9 video generation. After this, the AI agent node pushes the generated title into Airtable, and I check to confirm it has been populated correctly. Next, I'll go to key.ai to show where the API key comes from. Let me play a few sample VEO3 videos so we get a clear sense of what the model can produce. At the same time, we will check the logs to monitor the status of my video request. Here's where cost becomes important. Generating a VEO3 video takes 400 credits, while VEO3 Fast only uses 80 credits. Let's open the billing section. Here you can see the current price of credits in key.ai. Check this out. We can see here the workflow output, and the prompt we generated is sitting right here. Back in Airtable, the link's already dropped in, which is always a good sign. I'll hit it and the video plays straight away. That's the whole chain in motion: setup, output, link, and a real video at the other end. Before any workflow can run smoothly, there needs to be a clear way to capture what the user actually wants. Think of it like placing an order at a restaurant. You don't just say, "Bring me food." You specify the dish, the size, and maybe even the spice level. In the same way, the workflow needs a structured form so the system knows exactly what to generate. In this step, we are going to create an on-form submission node, which acts as the entry point for the workflow. This form is where users define what they want the system to generate. Through setting up a structured form, we will make sure the workflow collects the right details, like the expected output, aspect ratio, and model choice up front. This keeps the automation flexible and reduces the chance of errors later. I will start by adding the on-form submission node to the workflow and setting its configuration. Authentication will be set to name, the form title will be reference, and I will leave the description blank, though we can add one if needed. Next, I am going to add the form elements. The first field will be expected output, set as a text area so longer text can be entered and viewed in full. Also, I will toggle this field to required. After that, I will add the second field, aspect ratio, as a drop-down list. I will include two options, 16:9 and 9:16. Multiple choice will stay toggled off to avoid checkboxes, and I will mark the field as required. Lastly, I'm going to add the third model, select model, also as a drop-down list. I will add two options, VEO3 and VEO3 fast. Multiple choice will remain off and this field will also be required. To finish, I will configure the node to respond when a form is submitted and then execute the step. After setting this into motion, the workflow will be ready to gather structured inputs directly from the form. Now, when information first comes in, it's often messy or scattered, like notes scribbled on a napkin. Before you can actually use it, you need to put everything in order, label it clearly, and make sure it's stored in the right place. That's exactly what this step does. It takes the raw inputs from the form and organizes them into fields that the rest of the workflow can easily reference. In this step, we are going to create a set fields or edit fields node, which is essential for mapping structured data into the workflow. Capturing the user's input in a clean, consistent format ensures that every downstream step works with the same reliable data. I will begin by adding the edit fields node to the workflow and setting the mode to manual mapping. From there, I am going to define the fields. The first one will be brief, with a type set to string, and I will map its value from the expected output of the submission node. Next, I will add the field aspect ratio, also with a type set to string, and map its value from the aspect ratio selection in the submission node. Finally, I will add the field model, again as a string, and map its value from the model chosen in the submission node. After filling up those fields, I will execute this step. This setup ensures the workflow always has clean, well-organized data to pass through each stage of the process. At this stage, the workflow already has the user selections organized into structured fields, but those inputs still need to be transformed into a usable prompt. That is why we need the AI agent node. It not only generates the prompt, but also ensures the reasoning process is supported and the output is cleanly structured, ready for the next steps. For this flow, we are going to set up the AI model node with three key components: a system message to guide the model, the think tool to support reasoning, and the structured output parser to enforce a consistent format. After placing those pieces, the AI will always return responses that are reliable and properly formatted for downstream use. Just like in other flows, we will start by adding the AI agent node to the workflow and setting the configuration. The source for prompt is set to define below, and the prompt user message comes directly from the prepared script. I will then map the brief from the set field node into that script. The option to require specific output format is toggled on, with enable fallback model stays off. From here, I am going to add a system message, also from the prepared script, and then select a chat model. I will choose the OpenAI chat model and set the model to GPT-5 Nano. Next, I will configure the output parser. I'll select structured output parser, set the schema type to generate from JSON example, and provide the JSON example from the prepared script. For the last step, I am going to add the think tool and then execute the workflow. Now that everything is connected, the AI is now capable of generating structured, schema-compliant outputs that the rest of the workflow can depend on. Alright, the workflow has collected the user's input, structured it, and generated a title through the AI agent node. So for our next step, I want to make sure that the result doesn't just disappear. It needs to be stored somewhere reliable. We will be needing Airtable here. We are going to use it as the central place to keep generated titles, so everything stays organized and easy to reference later. In this step, I am going to add a create a record Airtable node to the workflow. The configuration is straightforward. The resource is set to record, and the operation is set to create. I will then select the correct base from the list and choose the target table where the data will be stored. Once that is ready, I will switch the mapping column mode to map each column manually. From there, I will remove any unnecessary columns and map the title directly from the AI agent node. After completing the mapping, I will execute the step. Then, I'm going to Airtable to confirm that the new record has been created successfully and that the AI-generated title is showing up in the table as expected. Now that the workflow has the structured inputs and the generated title stored, the next step is to trigger video creation. To make this possible, we will connect directly to Key.ai's API instead of going through the website. This means the workflow itself can send the credentials and prompt, and Key.ai will return the video automatically. Let's add an HTTP request node to the workflow and set the method to post. The request will point to the Key.ai endpoint that handles video generation. Query parameters will not be included, but headers need to be enabled. For the headers, I am going to add authorization as the name and provide the API key in the required bearer token format. This ensures the request is authenticated and accepted by Key.ai. Next, I will enable the request body to set the content type to JSON. The body itself will be specified using the prepared script, which contains the details that must be sent to generate the video. Once this configuration is complete, I will execute the workflow. To make the workflow easier to follow later on, I'm also going to add a short note at the very start, explaining that this step is responsible for handling the API call for video generation. After sending the request to generate a video, the workflow needs a way to check on its progress and retrieve the results. The GET request handles this step, while the POST request starts the task. The GET request allows us to track it and pull back the details once Key.ai has processed the video. Keeping these two steps separate makes the workflow clearer and easier to maintain. To set this up, I'm going to add a new HTTP request node and switch the method to GET. The request will target the endpoint that provides information about the video record. Since this type of request depends on knowing exactly which task we are checking, I will turn on query parameters and add one called task ID, mapping its value from the post request. That way, the workflow looks up the specific video that was just created. Headers also need to be enabled here, so I will add authorization and include the API key in the required bearer token format. This gives the request the proper access it needs. Unlike the post request, there is no need for a request body, so that setting will stay off. Now we will run the workflow to confirm it successfully returns the video status and details. To make everything easier to follow later, I am also going to rename the earlier post node so the two requests are clearly labeled in the workflow. After checking the video status with the GET request, there needs to be a plan for cases where the video is not finished yet. Instead of letting the workflow run endlessly, we will set up a controlled loop that waits, retries, and eventually times out if the process takes too long. To build this, I will first add an if node to the workflow and rename it for clarity. The condition type will be set to number exists with the value mapped from the complete time field in the get node. This configuration tells the workflow whether the video has finished generating or not. Once that's in place, I will run the steps so the condition is ready to branch. If the condition is false, I am going to add a wait node under that branch. We need to rename it clearly and configure it to resume after a 1-minute interval. This gives the workflow a short pause before checking the video status again. After the wait, I will insert another if node. This one uses the run index to count how many times the loop has repeated. I'll set the condition to check if the value is equal to 15, which caps the waiting time at 15 minutes. From here, the workflow splits again. If the limit has not been reached, the false branch loops back to the get node so it can check the video status again. If the limit has been reached, I'm going to add an Airtable update record node to the true branch. For the Airtable configuration, I will set the resource to record and the operation to update. The correct base and table will be selected from the list, and I will rename the node for clarity. The mapping column mode will be set to map each column manually. Under the values to send, the ID will be mapped from the Create a Title node, and the status field will be set to failed. This ensures Airtable updates the record to mark the video as failed if generation takes longer than 15 minutes. When the workflow confirms that a video has finished generating, the next step is to handle it properly. Instead of marking everything as complete right away, the workflow needs to validate the aspect ratio and then update Airtable with the correct status. This makes sure the record accurately reflects what was produced and prevents errors if the aspect ratio does not align with Key.ai's supported formats. In the true branch of the check if video is generated if node, I will add another if node and configure it to check the aspect ratio. The first value will be mapped from the aspect ratio stored in the edit fields node, and I will set the condition type to is equal to with a value set to 9:16. This step ensures the workflow validates which format was selected before updating Airtable. Once configured, I will execute the step and rename the node to something clear like check if 9:16. From here, I will go into the true branch of that node and add an Airtable update record node. The configuration will be set to update a record in a chosen base and table from the list, and I will set the mapping column mode to map each column manually. I will map the record ID from the earlier Create a Title step and set the status field to generated. Renaming the node for clarity keeps the workflow easy to follow. Airtable will show that the video has been generated successfully. For now, the update only confirms the status. The step for adding the video URL will be included in the next part of the workflow. Right now, the workflow is already marking videos as generated, but the record becomes much more useful if it also includes the actual video link. This way, the video can be retrieved, reviewed, and shared directly from Airtable without extra steps. To make that happen, I am going to edit the Airtable update record node and look at the values to update section. Under the URL field, in the values to update section, paste the expression. This ensures that when a 9:16 video is returned, the workflow automatically saves the generated URL into Airtable. From then on, every finished record carries both confirmation of success and a direct link to the video, making it easy to review or share without extra steps. After the workflow confirms a video has been generated in the 16:9 format, an additional request is required to pull the high-resolution version. Not all aspect ratios support full HD, so this step is what ensures the 16:9 outputs are delivered in 1080p. The result is a higher quality final video, ready for professional use in platforms where sharp visuals matter, such as YouTube or client presentations. I will add a new HTTP request node and configure it to run as a GET call. The request points to the endpoint that provides the 1080p video file. Since the system needs to know which video to fetch, I will turn on query parameters and map the task ID from the previous node. Next, I will enable headers and add authorization with the API key written in bearer format so the call is properly authenticated. The body is not needed for this request, so it stays off. After everything is entered, I will run the workflow and confirm that the correct video is returned in full HD. Finally, I will rename the node so it's clear at a glance that this step handles fetching the 1080p format. After requesting the 1080p version, the workflow needs a way to handle the situation where the video isn't immediately available. Rendering can take time, so rather than failing too early or hanging forever, the workflow should pause, retry, and eventually time out if nothing is returned. This creates a balanced system that is both patient and efficient. Let's add an if node and rename it so the logic is easy to follow. For the configuration, I will set the condition type so string is not empty and add the result URL field from the JSON response as the value. This ensures the workflow checks whether the video URL has been generated and confirms if the 1080p file is ready. For the false branch, I will add a wait node. I'll configure it to pause for 1 minute before resuming and rename it clearly so anyone reviewing the workflow knows its purpose. Once the wait is complete, another if node comes into play. This one tracks how many times a loop has run by referencing the run index. I will set the condition so that once the counter reaches 15, the loop ends. On the true branch of that node, I will place an Airtable update record node. For the Airtable configuration, I will set the resource to record and the operation to update. The correct base and table will be selected from the list, and I will rename the node for clarity. The mapping column node will be set to map each column manually. Under values to send, the ID will be mapped from the create a title node, and the status field will be set to failed. This ensures Airtable marks the video as failed if generation takes longer than 15 minutes. Through this setup, the workflow continuously checks for the 1080p video without running indefinitely, while also keeping Airtable updated with a clear outcome. The wait and retry setup needs one final piece to work perfectly: a loop that directs the workflow back to the 1080p check whenever the video is still pending. Without this connection, the workflow would stop too soon instead of continuing to check automatically. I will rename the node for clarity, then connect the false branch of the if node back to the get 1080p node. With this connection in place, the workflow loops smoothly whenever the video is not yet available, while still respecting the 15-minute cutoff defined earlier. Now, when a workflow finishes generating a 1080p video, the result isn't complete until it's written back into Airtable. Having the video URL and status recorded directly in the table makes the output easy to find later and keeps everything organized in one place. In the true branch of the check if the 1080p is ready if node, I will add an Airtable update record node and configure it to update an existing record. The resource will be set to record, the operation to update, and I will select the correct base and table from the list. To keep things organized, I will also rename the node clearly. Next, I will set the mapping mode to map each column manually. For the values to send, the record ID will be pulled from the earlier create a title node. The URL will be mapped from the result returned under the check if the 1080p is ready node, and the status field will be updated to generated. After saving these settings, I will execute the workflow and add a short note for clarity so future edits are easier to follow. Finally, I will open Airtable to confirm that the record now shows both the video URL and the updated status. So now you've seen how every piece of the system fits together, from capturing inputs to generating professional-grade ads with VEO3 to automating the entire pipeline inside N8N. What used to take agencies weeks and cost brands hundreds of thousands can now be done on autopilot for just a few credits. The real power here isn't just the AI model, it's the workflow. Once you have this built, you can feed in any product, any brand, and instantly spin up ads that look like they came from the biggest creative agencies in the world. That's what gives the setup its edge: consistency, speed, and scalability that no manual process can match. And this is exactly what I was talking about in the intro. Those viral VEO3 ads everyone's chasing, the million-view campaigns that cost brands 6 figures to recreate, you now have the blueprint to build them yourself, faster, cheaper, and more efficiently than anyone else out there. The tools are linked in the description, the workflows are right here, and the rest is up to you. Take this system, make it your own, and start running campaigns that look like they should cost a fortune but don't. Thanks for watching. See you in the next one.